There is a new jet taking the world by storm, and it is not owned by any private entity, but an agency. The X-59 Supersonic jet. This NASA jet, or X-plane as it is also called, is designed to fly faster than the speed of sound. But that is not what makes it a brilliant piece of aviation equipment. What is so unique about the X-59 is that it does not produce a sound, nor will you hear the disruptive sonic booms synonymous with supersonic aircrafts. The X-59 is as silent as a mouse when in flight, and it can travel at breakneck speed. Hello and welcome to yet another exciting video episode, where we review current trends in the technological world. In today's video, we will tell you all you need to know about NASA's brand new supersonic jet, the X-59. How fast will the X-59 supersonic jet go? Keep watching to find out. The NASA X-59 Supersonic jet is regarded as a quiet craft designed to fly faster than sound can. This amazing aircraft is built to fly over several states in the US to demonstrate the soundness of its technology. The engineers who worked on the jet say that people on the ground will not hear a sound when it flies past, and even if they do, all they will hear is a quiet sonic thump. That is if they hear it at all. NASA commissioned Lockheed Martin to build the jet so it can be used to gather data from community overflights. The data gathered will be transmitted to a control unit, where it will be used to develop new aviation rules for the construction and release of supersonic jets that will undertake commercial flights in the near future. The project has been on for some time and continued into 2020 despite the challenges of the global pandemic. The final release date for the X-59 is billed for 2023 or 2024. Why does NASA need a supersonic jet? The reason is simple. The US Space Agency is flirting with the idea of sanctioning commercial supersonic flights in the near future. To make this possible, data is required to determine how the civilian population on the ground will react to supersonic technology. As you already know, supersonic jets are not common and very little is known about how the public will react to it. The potential hazards of having such jets in our airspace makes future research imperative. And research without data is impossible. During reconnaissance flights across major cities in the US, data will be collected from the jet and transmitted to local and international aviation regulators. With valuable data at their disposal, they will be able to set new rules to make commercial supersonic flights over land possible. This development will open up a whole new market for the production of supersonic flights. According to Peter Cohen of NASA's Low Boom Flight mission, he said that this mission is the culmination of decades of research, and with the X-59 we are continuing to pioneer a future of aviation in which we will see drastically reduced flight times for global traveling passengers. The X-59 is undergoing construction at Lockheed Martin's Skunk facility in Palmdale, California. One of the major features of the craft will be the external vision system. Also called an XVS, this system is basically a forward-facing camera with a display system that lets the pilot see the external area of the craft via an integrated augmented reality. This feature is a major design necessary because the craft does not have a forward-facing window. Without one, the pilot can't see what's in front of him, but with the XVS, sight is possible. Placing a window in front of the X-59 is not feasible because of the speed at which the jet will travel. Secondly, the elongated nose, as well as the fuselage profile, only allows engineers to place the cockpit farther away from the front. Lockheed Martin engineers conducted several tests on the XVS dating back to August 2019 before qualification results were attained after several rounds of tests. The progress of work has continued according to schedule. Recently, major progress was made on the wings of the X-59 using a robotic and bolting auto-drill system called Cobra. This Cobra technology enhances drilling operations and is an essential part of the assembly process. Pallet brackets have also been installed to make room for the flight test instrumentation systems and the XVS. The brackets actually mark the first time NASA has supplied a component to Lockheed Martin for the construction work this far. Several other milestones have been achieved in recent months, some of which include the delivery of major spare parts of the jet that will be installed very soon. These spare parts are the vertical tail, an extended nose, and General Electric's F414GE100 turbofan engine. Despite the challenges caused by the pandemic and some other experimental difficulties, work has continued on the X-59, with the assemblage to be completed in a few months' time this year and a first test flight to be carried out in 2022. Despite the delays, the plaudits have been rolling in. In a statement released by NASA's head of the LBFD project, Craig Nicholl, he is quoted as saying, "The team has shown remarkable resilience, and we're excited to see the visible progress on X-59 assembly and integration every day. Although we have had some challenges in 2020, the team has responded well by updating plans and continuing to make progress. We're looking forward to several important milestones this year. The milestone Mr. Craig was speaking of is the completion of the wings and installing them to the fuselage by the end of 2020. Going further, the head of the X-59 project at Lockheed Martin gave the following progress report. "We are over halfway complete with the build of this one-of-a-kind X-plane," said David Richardson, X-59 Program Director, Lockheed Martin Skunk Works. "We will soon complete the closeout of the wing, which is the central structural anchor of the aircraft, and we will then prepare for mate of the empennage, fuselage, and the distinctive super long nose. The team has done a phenomenal job of advancing aerospace technology and working through challenges to drive progress, all of which has been enabled by our close partnership with NASA." With the assurance that schedule adjustments will not disrupt the timing of the project, the International Civil Aviation Organization and Federal Aviation Administration are putting modalities in place to come up with a regulatory framework to make supersonic flights across international airspace possible by 2027. Regulators plan to use data obtained from the X-59 to decide whether regulatory changes will be required on existing rules to make room for supersonic flights. Government bureaucrats are not the only ones putting finishing touches to their plans. Even NASA's aeronautic engineers are preparing for low-boom demonstration flights. These demonstration flights will be necessary to evaluate the degree of shock waves emitted by the jet, which could lead to loud sonic booms or quiet thumps. Engineers will require shockwave visualization tools, acoustic variation tools, and in-flight pressure measurement devices. These are some of the tools that will be required for air and ground testing. Here are some of the stats of the X-59. Preliminary design of the X-59 started in February 2016. The jet is expected to be delivered in 2021, with the test flights expected in 2022. The expected speed of the X-59 is estimated to reach 937 miles per hour and fly at an altitude of 55,000 feet above ground. The jet will create low-level sounds of 75 decibels. NASA received 3 inquiries from companies, with Lockheed Martin winning the contract worth $247.5 million to design the craft. The X-59 will be monitored by 20 noise sensors, with the ground experience designed by 400 residents who will receive a weekly wage of $25 as compensation. The fact that members of the public are part of the planning process is a step in the right direction, since human populations are the ones who are mostly impacted by modern aviation technology. The launch of the X-59 signals a new beginning for the global aviation industry. If everything goes according to plan, we might just see fast-flying supersonic jets flying our airspace and cutting flight time frames by up to 50%. Such a development will make the planet smaller, as travelers will be able to travel across long distances in less time. Before ending today's video, let us know your thoughts about NASA's advanced engineering aspects in the supersonic jet. And don't forget to subscribe. We'll see you in the next video. Take care.